Good afternoon, everyone. I'm Moses Martinez Camarena, and this is my presentation on the final design project. For me, it was an UMSL towel bar. So my first step was finding the problem. When I was thinking about what I wanted to create for my design, I wanted something that was meaningful and that would improve some aspect of my apartment. Um, and my towel bar was definitely the thing I wanted to work on. It was old. One of the hangers had a crack in it already, and the bar was very bent and deformed already from the weight from previous towels and previous owners. There was not enough space between the bar and the wall to place two towels on top of each other, so you could only have at max one towel on each side. So I wanted a cheap and quick way to create a new towel bar without having to go outside and buy one that potentially wouldn't even have the same sizes as the original. So I ended up using that as a perfect opportunity to 3D print it. So my design steps were pretty straightforward. Since I already had the actual parts from the old towel bar, I ended up taking them apart and taking measurements of the existing hangers and bars. Um, I created rough sketches from the parts using the measurements, as you can see to the right. This is mainly the loft and the base, um, but I just would place the measurements down. I would adjust them slightly to make them easier to place in SolidWorks. And for the fillets, I placed those on my own just to make sure they would fit to the part on SolidWorks as well. So some of them were adjusted. Some of the radii, the radii were adjusted as well. Um, Again, to fit the changes in the part. Um, and the hangers were designed first because I knew they were either going to be created in one part or two parts, and it'd be pretty straightforward. But the bar was designed second because I didn't know how many pieces I'd want to split it up in because I knew the printer wouldn't be able to print the bar in one file. And then any of the measurements were adjusted after testing if they were needed to. So in the decision matrix, there are a couple of decisions I had to make before going into it. One of them was the PLA screws. I didn't know if I want to use the old screws or to 3D print some new screws. But I would end up not using the 3D printed screws because they were not as strong as the old screws. It was extremely feasible to print them and to use them, but they kept snapping when they were getting screwed into the wall. So it was more effective and there was more security behind using the old screws. The rod would be 3D printed as well, although the wooden bar was stronger and less likely to snap because it was all in one piece rather than separate pieces. But I still wanted to try printing the bar because I had the time and it was extremely feasible to still design a bar that could work. And then one of the things that didn't work out as well is printing the bar in one file. There was no feasibility in that with the 3D printer that I currently have because the length was 558 millimeters and the tallest that this could print at was 150 millimeters. And then extending the loft base of the hanger would also allow for more space. So that's exactly what I did. The strength wouldn't change. It was extremely feasible and the print time would increase slightly, but it wouldn't increase significantly. Some of the alternative concepts, again, based off the decision matrix, some of the things I wanted to do, but ended up not happening. This is more of a backup plan. I would use the old wooden bar instead of the PLA bar if it didn't work or if I didn't have time to adjust any of the measurements. And to use 3D printed screws rather than the screws that came with the old towel rack. That wasn't probable because they kept snapping when they were getting screwed into the wall. Printing the bar with one file, there was zero feasibility in that, so I ended up not using that concept. Making the bar longer, it was feasible. It would extend the print time, but it would not fit the design of the old bar, and it would also be weaker in the center and not hold as much stress as it normally could. And then create the hangers without the bottom holes. That was the original design, but there was less stability and less strength connecting the two pieces, even if they were printed together. And I'll go into that a little bit later. So here's the left hanger design. Most of the measurements were kept from the old hangers. The only things that were changed were the radius of certain parts and the fillets. Those were just created, those were just adjusted to work better in SolidWorks. And the height of the loft was changed to 80 millimeters instead of 77 millimeters. That was just to create more space between the wall and the bar so I could place more than one towel on top of each other. The UMSL logo was also added for some personality. I wanted to make it personal. Since I go to UMSL, I thought it'd be a pretty neat design to add, and it would not affect the print time at all. The right hanger is just a reflection of the left hanger. I just flopped the extruded cut and the base from each side because it's down the center. The extruded cuts in the bottom were added for screws to reduce the likelihood of the loft snapping off the base. So I used that off the old design as well, even though I had originally not done it. But it definitely helped in keeping the base together, even if it was all printed in one piece. And then the towel rod design, I ended up making it into 5 pieces. It was the most feasible way to do it because, again, the max is 150 millimeters of height. So the beginning piece and the end piece were each 129 millimeters, and the 3 middle pieces were 100 millimeters. So the total was 558 millimeters, which was the overall length of the actual bar. So it ended up working perfectly. And then the little extruded base here was just to make sure that they could connect easily and there would still be strength and less likelihood of it snapping or disconnecting. So the extruded base had a 14.7 millimeter diameter and about a 24.7 millimeter length. And it was shorter and smaller than the extruded cuts just to make sure that it could still fit and to fit into that tolerance as well. And it'd still be snug and tight even when it was put in. And the extruded cuts had the 15 millimeter diameter and 25 millimeter length, again, to adjust and make sure that they would fit properly. And when it was time to assemble them, it was easy to place them, but for those last couple of millimeters, tapping it with a hammer helped significantly, and they fit perfectly in the end. And then the printer settings, here's some quick printer settings. The infill I set at 20%. It was pretty strong that way. It helped reduce the print time, and all the prototypes came out perfect. The printing temp was at the regular 200 degrees Celsius. The plate adhesion was brim. I always support using brim because you can either tape that brim down while it's printing to reduce the likelihood of it moving around or getting detached from the printing bed. I use normal quality, and then the initial layer speed of the print I set down to 40 millimeters per second, and that was just to make sure that the extruded cuts would come out properly because the extruded cuts were also placed face down onto the printing bed. So that's the first thing that was printed. So I wanted to make sure that the highest quality was placed in that, and slowing down the initial speed was crucial in making sure that the extruded cuts would be to size. And here's the manufactured prototypes, the assembled rod, and the right hanger. So you can see how it came out very well. Each hanger took about 6 hours to print. It was a little long, but I only had to print each one once. The bar was split into 5 pieces when printing, and you can see each separate piece there in the picture. And each piece took about 2 hours to print, with the beginning and the end pieces taking about 2.5 hours each. And with one of the hangers I did have to print a second time, but it was mainly an issue with the printing bed not being aligned properly. And that goes into my print risk. There is a risk when it comes to printing these parts. The printer had not printed the left hanger properly, and without the screws in the bottom for extra support, the loft just snapped before I even got a chance to test it. So adding those two extruded cuts in the bottom helped solve that issue with adding the screws, and correcting the printing bed to be level and making sure it wasn't shaking when it changed from the base to the loft. Definitely helped in making that connection seal better than it had originally been. And then one of the testing failures was the screws. Since it was quick to print, I did try printing them and seeing how they would work. But they kept snapping very easily. And if they did get through, they would start to bend very quickly. So I ended up deciding not using this product at all. And the better option was using the old screws. And the other testing failure was the bar as well. Having the bar printed in 5 pieces made it difficult to find ways to attach it for sure. And the first design, I made the extruded base a little too small in diameter. So I had to go back and increase that diameter, as well as the diameter of the extruded cuts of the other pieces as well. So that helped in stabilizing a little bit more and reducing the likelihood of it snapping with having a bigger base and less chance of it snapping in the center here in that weak spot, as you can see in the picture. Testing afterwards went very smoothly. And here's the testing validation, fully assembled onto the wall. The old screws you can see on there. The measurements of the extruded cuts were corrected for each part and the extruded base. The towels were held firm. There was less displacement than the original design for the towel bar. So that was a positive. And I believe the testing was successful, as the towel bar was able to hold up 4 towels with only little displacement the second time around. And also, it's still holding the towels up currently. It has not snapped. It has very little displacement, and it is still working properly. So I deem this test a success, and the design is a success as well. I do want to keep working on a better way to make the towel bar, and finding different ways to make it so it has even less displacement. So in conclusion, the design was successful and it managed to hold up the 4 towels with minimal displacement. It was a cheap way to create a new towel bar without having to go out and buy one, and using some of the old parts as well, rather than having to go out and buy new parts or print new parts. The overall print time of the product was between 22 and 24 hours. So it's not that it does not take that long to print, and it could take you 2 to 3 days overall if you wanted to spread it out a bit. The assembly is quick, and the process of actually putting it together and attaching it to the wall is very quick as well. It's not that difficult to make, and it's extremely feasible, and I'm happy with the product I made. So that turned out very well. That's it. Thank you.